Truly my pleasure to bring Cisco AI Enhanced RRM to you today. For those who are not in the know, RRM Radio Resource Management has been, well, it was a Cisco innovation when we started doing centralized measurement of over-the-air measurements. And back in the day, it was fairly simple with 3 channels. 5 gigahertz added some complexity, but RRM has done a great job for what it does. It's based on a controller today, and it collects up to 10 minutes of data is what it's making its decisions on. It's dynamic. It reacts to things in the environment. We've got a couple of bypasses. So it's done a great job for us. Obviously, there's been some growth in the Wi-Fi market over the years. We have just reached into Wi-Fi 6E. We've made RRM adapt to an awful lot of things, innovative features, dynamic bandwidth assignment, DFS changes, optimized roaming. So there's been an awful lot done with RRM over the years as the standards have progressed and as Wi-Fi as a technology has reshaped itself and become much more important in our economy. So while RRM has evolved, it's maintained its flexibility. We're still able to troubleshoot and get down to the root core of its challenges, but it has gotten more complex, and that configuration, the amount of knowledge required for it, has continued to escalate as well, particularly as we do things like increased density, and we moved from a coverage-based to a performance-based model where we require many APs in very high density environments to provide the kind of throughput that people are looking for. Not surprisingly, over the years, I've got a knob for just about everything, but the controller's gotten just a bit busy. So AI Enhanced RRM, what is that doing? Well, hopefully it is going to bring me much more insight into the RF environment. It's certainly collecting a lot more data. We've got adapter parameter optimization, being able to tune the network for the job it's doing at the present time. Actionable insights. One of the key things is being able to give you strong and accurate insights, actionable insights in what's going on in your RF layer at any given point in time. And more than that, giving you feedback on your configurations and the things that you should maybe be considering based on the observations that the cloud is making. We then combined with the visibility and the AI enhanced learning algorithms that this is going to provide a big boost in operational efficiency. Of course, the target for this is to, provide the ability for normal administrators, which are working every technology from dawn to daylight, to be able to understand what the system's telling them and react quickly because it's a critical access layer. Some of the things that we can compare. Traditional RRM is working off of a snapshot every 10 minutes. It is working off of over-the-air measurements. AI Enhanced initially brings a 14-day database that we have to work with in the Cisco AI Analytics Cloud. Config workflow is very manual today. You do need to understand the environment that you're going into. I can, of course, tune RRM to just about anything. Not everybody has that kind of background or is able to do that. So that's one of the things that was really important to me, was that we got the ability to audit configurations, minimize the number of knobs, and be able to just give frank advice or make changes where needed to preserve performance. Segment services, yes, I can segment it by buildings. RRM Control Center brings me new visualization. Unlike the controller UI or some of the fantastic tools that we've written about dumps from the controller, there's still snapshots in time. We also have interrupt cognizant. Okay, one of the use cases today that is, it's hard to see because I do realize that channel changes are still disruptive to clients, particularly voice clients and things like that. We see RRM getting frozen, which sets you up for one of those 10-minute intervals that we make decisions on being at midnight rather than the busy part of the day. So there is scheduling for RF tuning. There is the concept of a busy hour during the day. So there's just a lot of things we can bring with that. Reward-based decisions, yes, we are monitoring exactly the same scores that we pioneered with the wireless config analyzer health scores. So there's no transition pain in that. If you understand or have used any of those tools, you're going to find this very, very familiar. We do have, and this is still on the roadmap, I just saw demos of it. We have a predictive mode where you can actually make some of these configuration changes and see the results in the dashboard, and then troubleshooting. It's integrated right into the dashboard. Hopefully, all in all, this is going to make a much more easier experience for new administrators. Even savvy expert administrators are going to find that there is definitely something in this for everybody. System is architected around Cisco's DNA Center, which you do have to provision a controller. But once this is done, you're using that for the telemetry flow as well as for the control link between the AI Analytics Cloud, which is where the RRM RF group leader, or what used to be the RF group leader, does reside fully in the AI Analytics Cloud. Cisco DNA Center provides me the path for configuration, also, again, the telemetry and the control channels. And then the Cisco 9800 series controller is the minimum requirement. You can't be on AirOS for this because of the telemetry requirement in the cloud.
Is DNA Advantage required, or can you get that?
Yes, this is included with the DNA Advantage. And by the way, that's a great point. This is currently released in a CA load, so it's controlled release right now, but it is out there in the latest Fray build, which was released. Onboarding a site requires that we first subscribe to Cisco AI Analytics services. You're going to enable that. You're going to enable the AI enhanced RRM. You're going to go ahead and provision the controller. We've got a brand new brownfield learning algorithm that will take the controller configs and convert those into DNAC configs, so it eases the pain of that onboarding, or the intensity of that onboarding significantly. And then you're going to create and assign an AI RF profile under DNA Center, and that is going to be the trigger that converts the controller over to AI RRM. When you go to onboard the WLC from the DNA Center console, you're going to select the sites that you want to apply this to. Now, it all has to be on the same controller. You can't run legacy RRM and a mixture of AI RRM sites. So if you're not sure of what's on the controller, the algorithm is going to be very clear that if you select something that has multiple sites, or you select a site that's on a controller that has multiple sites, it's going to be very clear about letting you know that this site has dependencies and you're about to convert everybody. So don't have to worry about that. What happens at the WLC? Well, this is where RRM, again, it's a fairly simple algorithm if you take a look at the blocks to it. But this lends itself very, very well to this type of a treatment because we have the concept of an RF group. When you push the AI enhanced RRM profile down to the controller, it basically replaces the profiles, the RF profiles that are on the controller. And what happens at the controller level is it designates a new RF group leader. That RF group leader is then the AI cloud. And once that is done, you're going to see everything change on the controller. For instance, the remote member, and it's just a member of another RF group. And you're going to see the group name change. And if you had any other controllers, if you were currently the active group leader, they will regroup and they will build another RF group leader and stay on legacy RRM while this controller shifts to being the only member of that RF group in the cloud. So we said AI Analytics Cloud a whole bunch of times, and if you're like me, this cloud thing seems to be catching on, so I'm embracing it. But what happens if my cloud goes away? Fortunately, a lot that happens in RRM doesn't require lightning speed, but we've thought about that. Since this is a remote group leader, if the group leader goes away for any reason, if I lose that for more than 20 minutes, I'm going to revert back to being an auto leader on the controller. What happens when you do that? Well, if you're the auto leader, you're going to lean back on your own RF profiles and configurations, which we push to you from the AI Analytics Cloud already. So you're going to run the same RF profiles. You're going to run probably not even aware unless you go to the control center and take a look and see the message there that says, hey, you're offline with the AI Analytics Cloud. So it is very graceful recovery, and you may not even know if it flips and flips back. Of course, it will be logged. So how about if we take a walk through the control center cloud? All right, so this lab, this is my lab in San Jose that we've got brand new setup of AI enhanced RRM. It's actually still in the learning mode. The meat of this is going to be under assurance. It's going to be under the enhanced RRM control board now. You're going to be able to see sites that are on AI versus sites that are not, based on this AI icon that's sitting right next to the site level. So it's very visual. This part of it's the part that thrills me because getting RRM information has often been laborious and involved a lot of text files, and that has not gotten easier as controllers and densities on controllers have just continued to get larger. So right across the top, we're giving you all the information that you need to understand the situation very quickly. We've got context of 24, 7 days, or 14 days. Your band selection, the AI RF profile that you're actually running under, you can click that and go view the profile. And then you see the next run here. AI RRM runs every 30 minutes. Notice throughout the interface there is a copious use of tooltips. That is one thing that we made certain of, is that everything is explained and helpfully easy to understand. Below that, we've got a little banner message, but we've got what we call the hero bar, and this gives you the quick stats and the health of your RRM. I've got 13 total APs in here. Currently, I've got 4 clients. We may see this number bounce up and down. It's right now giving me 82 of 100 points on an RF performance score. One thing I noticed last night is that should be very green because it's very much in the good range right now. For some reason on this build, I don't have that green right now. And this is the latest build. This is not what's out there in Fray. This is actually on the very next release of DNA Center. There's been no RRM changes, and that applies to the last period within the last 30 minutes. And then it gives me a quick summary of my RF coverage, which my AP density is very high, and my connectivity, which is a signal to noise ratio score, the average of the clients operating under that network. 5 gigahertz always looks great. 2.4 gigahertz should be no surprise to anybody here. We're going to work with this as far as a bad example goes. Right below the hero bar, we've got 0% health on here. Can anybody guess why? We'll just go figure it out.
What is the reasoning behind that 30-minute RRM runtime? Just curious if there's anything specific
30-minute
that goes into
RRM
that.
Because of the amount of telemetry that we're collecting and being able to take a look, and 10 minutes is actually not a long time, right? If we're talking about an RF layer, things should happen slow there. So more analysis gives us more time to make good decisions with less changes. Is that helpful?
Okay. Yeah, that makes sense. Thank you.
Right below that, we've got what we call the insights. And insights, right now, you can see that it is currently learning. There's about a 1 to 2 week learning period, which doesn't mean that it's not optimizing the network. What it's learning right now is your busy times, your traffic patterns, and it's actually analyzing the configurations that have been put in place. And what I expect is within a week, I'm going to start seeing some of these insights. The first one, if I misset it, would be the busy hour, because that's very, very central to the things that we do. You can set this algorithm up to only make changes in the busy hour. There's a sensitivity setting in the RF profile that lets you say, be hyper aggressive on non-busy hours, or be semi-lenient, and we can even bias that towards performance versus client stability. So the insights are going to be coming in about a week. If you get an insight, clicking on the insight takes you to a full description of the insight, and I apologize I don't have that for a demo right now. There's a picture in the deck. But it gives you the full reasoning of the insight. It also makes a recommendation on what it should be. And then it'll even take you to the config, and in the standard of walk me, it'll walk you through changing that config, let you schedule the change to be immediate or take place at some future time. Right below that is all the information that you hopefully need to understand what's in the hero board. For instance, we're working with an RRM performance score of 0 right now in 2.4 gigahertz. I can tell you these APs are literally on top of each other in a lab full of other APs that are being tested actively. So it doesn't surprise me. However, if I take a look at RRM changes starting, my latest shows me that I do have several changes. If I view the details on this, I can view the details of each one of those changes by selecting it. I also have the familiar trend line. Now, by selecting that, it's going to give me a list of all the APs that are currently operating in the widget. And by selecting any of these, it actually gives me clear and understandable reasoning as to why this change was made, which is something that we've never had before and really kind of exciting. So that's just an example of how we're trying to make this information more accessible and more relevant. I think probably most people go through life hoping that they don't have an RF problem. Now, hopefully, we're going to take a little fear out of that. So that's the trend line for the RRM changes, then RRM performance, which is going to get to the meat of what we've got. This is bucketized, right? So the health score, 61 to 100, is where we consider it to be healthy. And this takes into account a whole lot of metrics. If I go down to the view details, we have some very bad performance going on right now. And if I double click on that or just select a period of time, I get the reasons why I've got poor performance. So this is going through each one of the categories that we're rating. It's a weighted metric. If I select any one of these pores, it describes what it's measuring, why it's unhappy with it, and then that leads you to making good decisions about what can be done about it. The next widget over to that, since co-channel interference seems to be my problem, and if I take a look, I've got 8 APs right now that are very high co-channel interference. I've got one that's at medium, and I've got 2 that are at low. So if I go into view the details on this, or I select the trend, again, I can go drill down to the actual APs, get that score. My impact in this case is inverse. If it's an impact of 100, it means it's 100% impacted. The reason for that is I've got co-channel interference at minus 53 dBm with a duty cycle of 91%. Again, lab testing. So that's a very, very bad thing for Wi-Fi, and it's called out here fairly clearly, I think. Let's go back to 2.4 gigahertz and get back into the happy land. Right now I'm running at 82%. If I take a look at the trend line in my RF changes, right, my RRM changes for 5 gigahertz, for the first time, I've got the ability to see what changed as far as channel width changes or band roll changes. So my AP numbers or my interface numbers are going to go up and down with things like FRA and some of the new features coming out with Wi-Fi 6E. So this gives me the ability to track that. It gives me the ability to see what happened when. And again, I get the same explanations that we talked about before. View details for 5 gigahertz. And I want to point out, any place that I've got an AP here, I've also got the ability to drill right down into the assurance menu. So I can drill very, very deeply down into what's going on with this AP and at a fingertip, take me right into all of the insurance information and the rich telemetry that we had to look at there.
Can this provide information into potential DFS events and help remediate this?
Well, hold on. You're kind of stealing a little bit of thunder, but we'll move right down to that. One of the things that we're always concerned about is where our APs are and what they're doing. If you take a look, I've got channel utilization, the number of APs that are on each channel, whether it's interference based or whether it's my own AP is going to show up here. Of course, if it's interference based, it's the orange, and if it's my own AP, then it's in that blue right there. And that also tells me how many radios are engaged in that. My count down here, and this is where we're talking about the DFS. If you take a look at this one being interference, on this one, if I have a radar hit, and I don't know if you can see that there, if I have a radar hit, then what you're going to see is that red dot up over that channel, which gives you an explanation as to why that channel may not be utilized. So this is giving me the spread of radios across the channel span, which lets me keep track of how good of a job the dynamic channel assignment is doing. If I go to trend data, this lets me drill down by channel. So you can get a very, very close view of each channels in particular. And you can drill down in a future release. We need the details tab on this, but the list of APs. One of the things that impacts RF configurations in Wi-Fi dramatically is density, and density is capacity. You can only have as much bandwidth as one AP can supply. And if you need more bandwidth than a single AP can supply, meaning you've got that many users, you need another AP and you need another channel. As APs get closer together, of course, they're still based on listen before talk. Things change. You have to change the data rates. You've got to change how you're mounting these things so that you can try and hide the RF from each other. You have to be concerned about how many channels you have and how many radios you're going to put in a room. So we tend to think of this as being more or less dense, and my idea of configurations or how we configure that changes with that. Capturing that was really important. So very, very simple metric here is network density. The network density metric is simply the number of APs that my current target AP can see that's above minus 70 dBm. And then we bucketize that. All of my APs right now are sitting smack dab in the middle of 10 to 15 neighbors. Well, there's 13 APs and they're pretty close to each other. The other thing that we contrast on this chart is the current click count. And the way that you would use this is, for instance, if I saw this stack of APs down at the, down at this end with the -5 or the less than 5, and my clients were all stacked up over here, and I had, a couple of APs and buckets over here, but not many clients. Right away, I've got a problem. I've got more users than I've got capacity over here, and I need to start making some adjustments. So that's kind of the idea behind it. Again, you've got the now familiar ability to drill down on this. At any point in time, pull the APs up. You can see who the highest on channel neighbor is, and I just used this at Mobile World Congress. We ran the press area on AI enhanced RRM, which I think you probably agree that's fairly bold. Large communications event, and pretty much all of the communications press in the room running on a new algorithm. That goes to its stability. We've had a lot of pleasure deploying this. I'll give you some stats on that shortly. The other factor that comes into play is power distribution. And this chart simply shows you where your AP's power are, what percentage of your APs that are neighbors are on that power level. So what this does is it lets you see what power level your APs are on and what the neighboring APs are on, so that you can find that outlier, right? I think we've all come in and found, 3 or 4 APs that are on power level 6 or 7 with one AP at power level 1 in the middle of the room, perhaps misconfigured, but it's no secret where all the clients are going to go. And then again, any transitions that are captured in this up to 14 days, we can drill down on it. You get the instant stats from the cursor. You also get the ability to drill down and view the details and link back in to all of the analytics that you have available to you in Assurance. Finally, diagnostics images. If you ever have a question of what really happened, or TAC wants to know what really happened, you have the ability to drop a service bundle, and that service bundle is filled with a lot of information that the engineers can use to figure out whether or not perhaps there's some new wrinkle in the algorithm, or perhaps you actually just need to change your configurations and respond to something.
Is DNA Center for this type of troubleshooting a one-stop shop? Like, is there any, does it cover all your troubleshooting information? Is there any reason you'd have to leave this and go back to the wireless controller or anything like that? Is there full coverage here?
Actually, not yet, because every time this came up in EFT, we made them find something else to put in there so I didn't have to leave here. So we've been actively engaged in this now for almost 2 years. Running it in the background, we've had it actively deployed in early field trials now. I think we're in our 8th month on that. So there's been an awful lot of learning. One of our partners on this has been UBC up in British Columbia. Fantastic university, really good friends. They have been extremely helpful and very gracious in providing us multi-floor buildings. We've thrown pretty much everything you can find in higher ed at this so far. What I can say is that the algorithm has been incredibly resilient, and the information that you get back, you'll see that RRM performance score at their peak times during the day. That'll hit down around 85%, but when you go take a look at the utilization, it's getting hammered. So it's really giving you a very accurate rendering of what your capacity is, how healthy that capacity is based against what's actually happening.
I have a question from a Twitter user on the AI RRM. Is
Sure.
the AI RRM based on your site and its learning, or is it based on a model in some way?
It's basing its insights on its learnings. The insights right now are limited. That's actually my next job, is to go in, and I can't wait to crack into that part. But it's based on what we're learning. That's why I don't get any insights until I've spent about a week gathering data. This was at Mobile World Congress at the press, and we had 5 gigahertz was fairly stable. 2.4 gigahertz, you can see I circled 154 rogues there. Mobile World Congress has 8 halls. They're all metal roofed, all metal sided, hard concrete floor. Usually have 200 different networks running in them because it's all communications vendors. And then we operate the network for the show, which has been a great honor since I think 2010. I've been engaged over there. It helps that it's in Barcelona. That meets with my favor. But we actually turned on the APs in the press room, and we saw an amazing amount of traffic cross this network. And the RRM performance was stellar. 2.4 gigahertz took a real heavy hit, but I did have a picture in here of some of the 2.4 gigahertz stats. It was actually usable in spite of all the rogue traffic and the high duty cycles. 2.4 gigahertz did get used in those rooms, and the performance wasn't bad. So that's it. That's the next chapter, and I'm looking forward to continue developing on this. It's been a pleasure working with this, and we are moving into more beta trials right now and adding more buildings and campuses.